Hello students, following question is a 2-mark question from a topic of transportation engineering, design of flexible and rigid pavements. Here it talks about that when no provision of reinforcement is provided in rigid pavement, what should be the spacing of contraction joints? Now to find out the spacing of contraction joint, we consider length L of the slab and draw its free body diagram. Now let us say that tensile force T is acting here, tensile force T is acting here. Now if we cut a section at midpoint such that this length is L by 2, then total frictional force that is acting on this L by 2 because of contraction, that should be equal to net tensile stresses that are generated as a result of this contraction. That's why this is called as contraction joint, and we know that whenever a material is subjected to contraction, the stresses that are set up are tensile in nature. So I am just equating this tensile force with frictional force. So tensile force on length of Le by 2 comes out as its mass multiplied by, and not mass, in fact weight multiplied by coefficient of friction. It should be equal to net tensile stresses. So it comes out as, now SC can be expressed as 0.7 FCK root 3 Newton per mm square. So this total, in fact I have written this as frictional stresses because I have just multiplied unit weight by length, and if I multiply this by area I will be having frictional forces. But in that case I have to equate it to net tensile forces, so A and A get cancelled out. So in nutshell we are just equating frictional stresses to tensile stresses. Now tensile stress will be given by 0.7 under root FCK divided by root 3, because it is mentioned that we have to use factor of safety of 3 against tension stresses. So LE comes out as, after this 10 to the power 4 is to convert this Newton per mm square to kg per meter square. So LE comes out as SC into 10 to the power 4 into 2 upon gamma into F. Just by substituting the values, this as 2400 kg per m3. F is given as 1.5. Length of or spacing of contraction joint comes out as 6.48, and it is very much clear from the diagram that this LE is not only the length of that slab portion, but it also represents the center to center spacing between two contraction joints, where one contraction joint will be provided here, one contraction joint will be provided here. Hence correct answer for this particular question is option A, that is 6.48. Thank you.